Identify the nature of the solute. Sodium acetate, NaC2H3O2, is an ionic salt composed of sodium cations, not to the power plus, and acetate anions, C2H3O2 to the power negative. Determine the process of dissolution. When solid sodium acetate is added to water, it dissociates completely into its constituent ions, not to the power plus, and C2H3O2 to the power negative. Analyze ion reactivity. Hydrolysis. The Na to the power plus ion is the conjugate of a strong base, an AOH, and is therefore a spectator ion that does not react with water. The acetate ion, C2H3O2 to the power negative, however, is the conjugate base of a weak acid, acetic acid. Apply the Bronsted-Lowry definition. A Bronsted-Lowry reaction is defined by the transfer of a proton, H to the power plus. Because the acetate ion is a conjugate base, it will react with water molecules by accepting a proton. Write the chemical equation. The resulting hydrolysis reaction is C2H3O2 to the power negative plus H2O is in equilibrium with HC2H3O2 plus OH to the power negative, since this process fundamentally involves a proton transfer from water, acting as the acid, to the acetate ion, acting as the base. It is classified as a Bronsted-Lowry acid-base reaction. The correct answer is option B, Bronsted-Lowry acid-base reaction.